I am Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about assembly language instructions. At the end of this video, the student will be able to understand what is assembly language, how the assembly language instruction can be framed, and what is the basic structure of the instruction, what are various mnemonics, what are advantages and disadvantages of assembly language based on its features. The basic agenda of this video is introduction, what is assembly language, what is assembly language instruction format, what are various types of instructions that are available in the assembly language, how to construct simple programs by using these assembly language mnemonics. In the previous video, we discussed about the various levels of programming languages. The language is basically used as a mode of communication by the user with the computer. There are three levels of languages: high-level language, middle-level language, and low-level language. Human understandable languages are generally considered as high-level language, and the machine understandable languages are generally considered as low-level language. The machine languages can also be again categorized into two: the machine language as well as assembly language. Machine language can be constructed the instructions as a stream of binary digits, the zeros and ones. So it is very difficult to understand and debug, write code in this language. So to facilitate readability, some mnemonics can be implemented in the machine language. Thereby, the readability can be increased. In case of assembly language, assembly language can be used certain code words to specify the operations performed on the operands. So here these code words can be generally referred as mnemonics. So it is a machine dependent, processor to processor. This list of mnemonics can be varied. So assembly language is very close to the hardware. The machine can be understand what is the purpose of the instruction the user is used in the programs. So here the mnemonics can be used in the assembly language. It cannot be directly understood by the machine. So there is need a converter, that is the assembler. Assembler is a program which is used to convert the assembly language programs into the machine understandable form. So here when coming to the interaction with the hardware, if you observe, low-level languages can have close interaction with the hardware. They can directly understood by the hardware. In case of assembly language, the assembler can be needed so that it can be converted into machine language and can be easily understood by the hardware. So the speed of program execution can be high in case of assembly language programs. So as we discussed in the introduction, assembly language instructions has to be used in the mnemonics. So here this code is less complex and easy to debug as well. So here the hardware has to be the interaction with the hardware with the program can be easily done with the help of assembler in case of assembly language. It has less interaction with the instruction set architecture. So these are the advantages of the assembly language programs. So it allows complex job to run in a simpler way. And here the memory is efficiently organized as it requires the less memory, and with less code we can execute the programs. And it is the speed of execution of the program can be high in case of assembly language. Why? Because it can be easily converted into machine language, which is clearly understood by the hardware or the machine. So it is mainly hardware oriented it requires less instructions to get the results. So the lines of code can be less as compared to the other levels of programming languages like middle level language and the high level language. And it is used for critical jobs and it is not required to keep track of the memory locations. So these are the advantages while discussing the assembly language. Now we have to discuss about what are the disadvantages of the assembly language. It takes a lot of time and effort to write the code for the same. Here, the code can has to be used the mnemonics and the operand. The programmer can has to aware these mnemonic pertaining to that particular processor. Then only the programmer can able to code the frame the instructions or the write the programs. So that's why it takes a lot of time and effort to write the code for the assembly language program. Next, it is very complex and difficult to understand. Why? Because the mnemonics can has to be understood by the programmer and the various varieties of addressing modes can be used to supply the operands for the instruction. So, if the programmer is aware of these addressing modes, then only it is possible to give to supply the operands for the instructions. So, it is difficult to understand and the syntax is difficult to remember. So, the programmer can has to remember the mnemonic and as well as the varieties of addressing modes, how efficiently he has to supply operands for the instructions. So that's why the syntax is difficult to remember. Next, it has a lack of portability of program between different computer architectures. So the language, assembly language is depending on the processor. So here the programmer can has to remember what particular mnemonics can be used in the particular processor. It needs more size of memory computation to run long programs written in assembly language. If the lines of code can be high in the program, then it requires large amount of space in the memory. So these are the disadvantages of the assembly language. So here the assembly language cannot be understood directly by the machine. So a software can has to be required which converts the assembly language program into the machine language. So here the assembler is the software that can be used to convert the assembly language program into the machine language. In the high level language, the natural language code can has to be written by the programmer. So here the programmer can use various looping structures, control structures in order to construct the program. For example, if you take this high-level language code, here the programmer can use if then else statement and while looping structure. So here in a natural language English, the code can be constructed in the high-level language. Next, in case of assembler, some mnemonics, LDA is the mnemonic and has to be used here, various mnemonics that can be pertaining to particular processor. Those mnemonics can be used in order to construct the assembly language program. Next, in case of machine language, the instructions can be specified by using the stream of bits, binary digits, zeros and ones. So this machine code can be directly understood by the computer. But for a assembly language, in order to understand by the machine with the help of machine code, a program can has to be needed. That software we can call it as assembler. And for high level language to machine code conversion, two softwares can be used, that is compiler, either compiler or interpreter for conversion of high level language code to the machine code. So in case of assembly language, assembler can be needed to convert the high level language code into the machine code. Next is assembly language programming process. So how to write the program in case of assembly language? So what are the essential softwares that can be required for the user in order to smoothly write the assembly language code and to execute and test the code? So one operating system program has to be needed by the user, which controls the operations of personal computers used for entire programming process. Next, the software that is required is the word processor or the any text editor where the user can enter the assembly language instructions. But this program has to be saved with a file name and with an extension of ASM, which can represent the assembly language program. Next is, after writing the code, an assembler program can be needed which can convert the assembly language program into the object code with an extension of the file .obj. After construction of the object code, text program can be used to run the program and to view the result. So these are the essential softwares that can be needed by the program in order to write the program and to convert it into the object code and how smoothly can be executed to view the result of the assembly language program. Now, how to write an assembly language instruction? What is the format or parts of the assembly language statement? Majorly here, we are having three parts while specifying the assembly language instruction. First, the user has to specify the label. Next, the instruction. Next, the comment. So, three parts are there in the assembly language instruction. One is the label, second one is instruction, third one is comment. The label is user-defined label and can be used to specify the location of the instruction. So here the program can be generally executed in a sequence, one after another, the statement of the instruction. So here, for example, 4 lines of code is there in the program. So the program can start its execution one line after another in a sequence. If the user want to alter this sequence of execution, then label can be useful. So here the user has to specify a label, for example, label 1, and in the program, if he specified, for example, jump to label 1, then the program execution should not continue to the next line of the instruction. It has to move or transfer the control to the specified label and start executing from that label onwards the program execution. So that's why the labels has to be used. It is an optional entry. So the labels are the user-defined words. Next is the instruction. Instruction is generally used to specify the two parts. One is the mnemonic that is related to perform what particular operation, and the operands. So on which data this operation can be applied. The operands can be supplied by using varieties of addressing modes. Those we will discuss in the next videos. So here the mnemonic that is pertaining to that operation and of that processor can be used, and later on after specifying the mnemonic, then the operand, the data on which this operation can be performed. After specifying the instruction, semicolon, comment. Comment is user-defined comment in order to specify the functionality of the instruction. It is an optional part. The assembler should not take into this consideration for translation. It is for user reference. So, 3 parts are there in the assembly language instruction format. One is the label, second one is the instruction, third one is the comment. But here in the three parts, the label part and the comment part are the optional, and compulsory and mandatory part is the instruction. Now we'll see the example how this format can be used. So here consider this example. Again, this again is the label. Label can be defined. The word after that, the user must specify the colon in order to indicate that it is a label. So here the label can be specified and it is terminating with a colon. The second part of the assembly language instruction is the actual instruction. So in the instruction, we have to specify the mnemonic and the operand. So here the mnemonic that can be used is the add. So here the add mnemonic generally used to perform the addition operation. But on which data this operation can be applied, that can be specified with the operands. So here it can be specified on the source operand price register and the AX. So accumulator register is the destination register. So here on which data that is stored in the registers, this addition operation can be specified or mentioned in the second part of the instruction. So the instruction has to be mentioned in two parts, the mnemonic and the operand. Later, the third part of the instruction is the comment. So after that, semicolon can be specified, and here this is the user defined comment. Add price of item to AX. So this is for user reference. The assembler should not consider these comments into consideration. So here add price of item to AX is the comment. So in the assembly language instruction, label, instruction and comment are the three parts, and the label has to be specified any user defined word terminated with a colon, and the instruction can be specified in the format of first specification of the mnemonic, later on the operands on which this operation has to be performed, followed by semicolon. The user defined comment can be specified, but this label part and the comment part are the optional, and instruction has to be the mandatory one in specifying the assembly language instruction. So this is the format of the assembly language statement. So after discussion about the format of the instruction, we have to look into the what are various categories of instructions that are available in the assembly language. There are three types of instructions are available: data transfer instruction, data manipulation instruction, program control instruction. The data transfer instructions are generally used for moving data from one register to another register, or for assignment and initialization purpose. These data transfer instructions can be used. Data manipulation instructions can be used to conduct any specific operation on the data stored in the registers. So these data manipulation instructions can be used to apply the operations on the data stored in the registers. And the next category is the program control instructions. The program control instructions can be generally specified to alter the execution sequence of the program. So what are the various categories of instructions under which mnemonics can come under each category? We have to discuss. First, we will look into the data transfer instructions. So data transfer instructions move data from one place in the register to another without changing the data content. So the register transfer memory and processor registers, the data can be moved, or between processor register and input output the data can be moved, or between processor registers In between the registers only the data can be moved. So here generally these statements are belonging to the data shifting or data movement statement, and these can be used for initialization and assignment of data for the registers. And the various mnemonics that can be used under this category of data transfer instructions are load, store, move, exchange, push, pop, input, output. These are the typical data transfer instructions. The mnemonic used for each operation is: for load, the mnemonic used is LD. For store, ST. For move, MOV. And exchange, XCH. For push, PUSH. For pop, POP. For input, IN. For output, OUT. So these are the mnemonics that are pertaining to the category of data transfer instruction. What is the load instruction? The load is used to transfer the data that can be to a register. Generally, the accumulator register involved in this operation. One particular data has to be moved to the accumulator or any register. The load instruction can be used. How we have to apply is LD, the accumulator or the register value has to be applied. Next is store, used to designate a transfer processor register to the memory. One processor register, the data has to be moved to the memory, then the store instruction or mnemonic can be used. How to apply them we will see later. Next is move. Move data transfer statement generally used that designate transfer between the processor register. In the processor, we are having variety of registers. The general purpose registers are ranging from R0 to Rn. So, depending upon the processor, the number of general purpose registers can be varied. In between these registers, if data has to be transferred, then move instruction can be used. Next is exchange. If user need to swap the content of one register to another register, two register content has to be interchanged or swapped, then the instruction exchange can be used. Next instruction is the input. Input transfer data among processor register and input terminal. By using the input devices, if user supplied data, so the data has to be moved from processor register to the input terminal, then input instruction can be used. Similar way, for the output terminal and the processor register, in between the data transfer need to be accomplished, then the output instruction can be used. Next, two instructions are push and pop. These can be used for stack organization CPU. So here the operands can be fetched from the stack. So here push instruction can be used to transfer data from processor register to the stack. Pop instruction is used to transfer data from stack to processor register. So these are the list of data transfer instructions and can be used to move data between the registers or from processor registers to the memory or processor registers to input and output. How to apply these operations? We have to discuss with an example. For example, in between register R1 and R2, the data has to be moved. Then we can use the instruction MOV for moving the content of the register. And what are the registers involved? This operation can be specified as operand here. So this is a register based CPU organization. So register names can be specified here. So here the content of register R1 can be moved to the register R2. Next is these push and pop instructions has to be applied on the stack based CPU organization. So here push is used to move the processor register value to that stack, and pop is used to fetch the stack operand, top of the stack operand into the processor register. So the content of push R1 means the content of R1 has to be inserted in the stack. Pop means on the top of the stack, what is the data is there that is moved to the accumulator. Next, the exchange instruction. Exchange instruction is used to interchange the register content to register content. So here the R1 R2 registers involved in the instruction exchange. So the operands are R1 and R2. The register content R1 R2 can be interchanged or swapped by using the XCHG exchange instruction. In this way, the instructions can has to be applied. So these comes under the category of data transfer instructions. The next category of assembly language instructions are data manipulation instructions. So the data manipulation instructions perform operations on data and provide the computational capability for the compiler. So by using these, the computational task can has to be performed. There are categories, 3 groups in case of data manipulation instructions. The first type of data manipulation instructions are arithmetic instruction. Second type of instructions are logical or bit manipulation instruction. Third type of instructions are the shift instructions. In the data manipulation instructions, 3 subcategories are there to facilitate the arithmetic, logical and shift operations. What are arithmetic instructions? By using these arithmetic instructions, the computational power can has to be introduced for the assembly language. So here the list of instructions that comes under category of arithmetic instructions are increment, decrement, add, subtract, multiply, divide, add with carry, subtract with borrow, subtract reverse, negate. These are the various list of operations that can be performed under the category of arithmetic instructions. Now we will look into what are the mnemonics that can be used to perform these arithmetic operation. To perform the increment operation, INC can be used, which is generally used to increment the register content by 1. Next, for performing decrement, DEC. For performing addition operation, add. For performing subtract operation, SUB. To perform multiply operation, MUL. To perform divide operation, DIV. And to perform addition with a carry operation, ADC. To perform subtraction operation with a borrow, sub B. And to perform reverse subtraction, SUBR. And to negate the operation, NEZ. So these are the list of mnemonics that can be used under the arithmetic instructions. So the first instruction in the arithmetic instruction is the increment. Increment is used in order to add a 1 value to the register content. Next operation is the decrement. To subtract a 1 value from the content of the register, then decrement instruction can be used. Next, add instruction is used to perform the arithmetic operation on the values stored in the specific registers. Next, subtract is used to perform the arithmetic subtraction between the specified registers. Next, multiply and divide can has to be used to perform multiplication arithmetic operation, to perform divide operation respectively on the values that are specified in the register. Next, the addition operation along with carry can has to be performed by using the add with carry. And the subtraction operation along with borrow can be performed if the user specified sub B instruction. Negation produces 2's complement of the value stored in the register. So these are the list of operations that can be performed under the category of arithmetic instructions. Now we will see how to apply these arithmetic instructions. So to increment, add one value to the register content R1, INC, the register must be specified. And to subtract one value from the register, DEC decrement, the register R2 can be specified. And to perform arithmetic addition between the registers, the add mnemonic and the registers R1 and R2 can be specified. Next, to perform the subtract operation, SUB R1, R2 can be specified. In this way, the arithmetic operations can be specified in the assembly language. The next category is logical and bit manipulation instructions. The logical instructions perform binary operations on the strings of bits stored in the registers. So by using these logical and bit manipulation instructions, the decision making capacity can be provided for the assembler. So the logical instructions consider each bit of the operand separately and treat it as Boolean variables. So these variables can have only the two states, either true state or the false state. So by proper application of the logical instructions, it is possible to change the bit values or to clear the group of bits or to insert new bit values to the operands stored in the register or the memory words. So for this purpose, the logical or bit manipulation instructions can be used. So we have to look into the list of logical instructions. The list of logical instructions are, the first instruction is the clear, complement, and or, exclusive or, clear carry, set carry, complement carry, enable interrupt, disable interrupt. To specify these operations, the corresponding mnemonics are to clear CLR, complement COM, and AND, ROR, exclusive or XOR, clear carry CLRC, set carry SETC, complement carry COMC, enable interrupt EI, disable interrupt DI. So these are the list of logical instructions that are generally used in the assembly language. Now we'll look into each instruction. The clear is generally used to clear to load zeros in the register. Next, complement is used in order to produce the ones complement on the value stored in the register, and is used to perform the logical and operation on the register specified. Next, OR, exclusive OR, can also be used to specify the OR logical operation, exclusive OR logical operation on the specified register bits. Next is clear carry. The carry value can be equated to 0 in case of clear carry. If you use set carry, the carry value can be set to 1. Next, complement carry means the individual carry bit can be complemented. Next, enable interrupt and disable interrupt. These two instructions can be used in case of interrupt handling. In order to check whether the interrupt is enabled or not, and to deactivate the interrupt, disable interrupt can be used. So these are the list of logical operations in the assembly language. Now we can look into how to apply these logical instructions. To specify clear operation on the register R1, to load R bits of the register R1 to 0, CLR R1. And in order to complement the bits of the R1, COM, the register R1 can be specified. If the user want to perform AND operation between the register R1 and R2, and R1, R2 can be specified. In this way, the logical instructions can be applied in the assembly language. Next, shift operations can also be used in the assembly language. The shift instructions operations in which the bits of a word are moved to either left or right. So, generally the shift operations are used for serial input of data. Shift instructions may specify either logical shift, arithmetic shift, or rotate or circular type of shift. So, there are three varieties of shifts are available: the logical shift, arithmetic shift, and the circular or rotate shift. In three cases, two possibilities are there: to transfer the bits to the left or to transfer the bits to the right. So, left and right shifts are available under these three categories of instruction. So, total 6 varieties of operations, shift operations can be performed. So, in order to support this, what are the list of operations, mnemonics that can be available in the assembly language? Logical shift right, logical shift left, arithmetic shift right, arithmetic shift left, rotate right, rotate left, rotate right with a carry, rotate left with a carry. So, here the mnemonics that can be used to support these instructions are: in order to perform logical shift right, SHR, and logical shift left, SHL, and arithmetic left shift, SHLA, and arithmetic right shift, SHRA, and to circular or rotate shift right, ROR, and rotate left, ROL. Rotation has to be done with a carry, RORC, and rotation can be done with a carry on the left side, ROLC. So, these are the mnemonics that can be used for these performing varieties of shift operations. So, how these shift operations has to be applied? SHR R1, 1. So, here shift right on the resistor R1 using the 1 bit. So, SHL R2, 2 bits on the resistor R2, the left shift operation can be performed. SHRA means arithmetic shift operation can be performed on the R1 with the 1 bit. SHLA R2, 1 means shift left arithmetic operation on the R2 with a 1 bit. ROR means rotate right or rotate circular right shift can be performed on the resistor R1. And ROL means rotate left or circular left. That operation can be applied on the content of the resistor R2. Next, RORC means rotate right with a carry on the content of the resistor R1. ROLC R2 means rotate left shift with a carry on the content of the resistor R2. In this way, the shift operations can be specified. So, here basically in the assembly language instructions, majorly 3 categories of instructions are there. They are data transfer instructions, next logical to perform data manipulation. We can have categories of arithmetic, logical and shift operations, and the third category of assembly language program instructions are program control instructions. These instructions are generally used to alter the sequence of execution of the program. So, these program control instructions specify the conditions for altering the content of the PC in order to alter the flow of execution, while data transfer and manipulation instructions specify conditions for data processing operation. So, the alteration of the program can be done in 2 ways. Whether the alteration of sequence of execution can be based on the conditional match. So, conditional transfer statement, unconditional transfer statements can be available in the assembly language. Conditional transfer statement means before altering the flow of sequence of program execution. They can has to test the content of the registers. So these content can has to be checked, or decision making can has to be done with the logical or bit manipulation instructions. Unconditionally means no condition checking can be done in order to alter the flow of program execution. The change in the value of PC as a result, the execution of the program control instruction causes a break in the sequence of program execution. And here these instructions provide control over flow of program execution and capability of branching in different program segment. So basically these instructions are mainly used to alter the sequence of or flow of program execution. Then we can describe about what are various program control instructions and what are respective mnemonics for each program control instructions. So here the list of program control instructions are branch, jump, skip next instruction, call procedure, return from procedure, compare, next, test. So here these are the various instructions available in program control group. And here to specify branch, BR mnemonic can be used, jump, JMP, skip, SKP, call, CAL, return, RET, compare, CMP, test, TEST. So these are the respective mnemonics that can be used to specify these program control instructions. So here the branch is generally used to shift to the specific label or address in the program execution. Next is jump. Jump and branch instructions are used interchangeably to mean the same thing to alter the program sequence of execution with the specified label. Skip is used to skip instruction, to skip the current program execution instruction and move to the next instruction. Next, call is used in order to call a subroutine. Return is used in order to return from a subroutine. Whenever a call is made for a specific procedure or subroutine, for example, consider this is the main program. And here this is the subprogram or the subroutine. Whenever a call statement can be encountered in the main program with calling with the specific subroutine, immediately this main program execution can be stopped and the assembler control can be moved to the specified subroutine and start execution of this subroutine instruction until it found the return statement. Whenever the assembler found the return statement, it again return back to the main program and resume execution of the main program. So this call and return can be used for this purpose. Next is here branching or jumping can be done based on two things: conditional jump and unconditional jump. In this jump and branch, unconditionally the flow of program execution can be altered. But if you want to perform conditional branching, then compare and test both instructions can be used in order to test the status register content, and comparing based on the various logical operations in order to perform branching. These two statements can be used. So these are the list of instructions that can be used for the program control instructions of the assembly language. Next, how to apply these examples of program control instructions. So, BR and the address, whatever specified address one, branch can has to be done. So, program assembler control can has to move to the specific location by altering the PC address with the ADR1 address. jump again. Again is a label specified in the program. So jump to this label and start the continuing execution of the program from there. Escape is to skip the current instruction execution and move to the next instruction. Call fun1, function 1 is a subroutine. So it starts the main program execution, suspends the main program execution and move to the function 1 and start executing the function 1 program execution until it found the return. Whenever return found, it has to resume to the main program execution. RET is the return which is used to return to the main program execution. CMP R1, 0. So the R1 can contain the 0 value. That comparison testing can be done by using the CMP. Test R1, R2. So whether both are equal or not. Like that the testing has to be performed. Or by using the status register also testing can be done. That we will see in detail in the next videos. So these are the list of program control instructions and how they have to be applied in the assembly language. Now we have to discuss about the sample assembly language program instructions. So based on the 8086 mnemonics, how these operations can be performed. So this is the initialization and the addition operation how can be performed. First, moving the value 7 to the DX register. So MOV DX, here depending upon the addressing modes, the operands has to be specified. Directly the value has to be moved to the register. Next, move AX, #09H. So the value of 9 is moved to the accumulator. Then we have to perform on these two the addition operation. So add AX, 00H. So these two values has to be added and the result is stored in the accumulator register and is used to indicate the end of the program. In this way, the assembly language program can be constructed to perform the addition of two numbers. How to perform the subtraction of the two numbers? So here, after initialization, the two value can be moved to the DX register. So #02, so it is moving directly to the DX register. And #088 value is moved to the accumulator register by using the move mnemonic. Next, on these two values, the sub B subtract with a borrow operation has to be specified on these registers. And the result is stored in the accumulator and end indicates the end of the program. In this way, simple assembly language instructions can be written by using the specified mnemonics. And this example is doing the subtraction of the two numbers. Similar way, after moving the two values to the DX register and AX register, here the multiplication operation can be carried out. MUL, the multiplication operation can be carried out and the result is stored in the AX register. And division of two numbers can be carried out with the DIV mnemonic by moving the two operands to the respective registers of DX and AX. And here the value has to be stored, the result is stored in the accumulator register. So these are, in this way, the arithmetic operations can be applied with a simple assembly language programs. Now, how the jumping operations can be implemented? The program control state instructions can be implemented in the assembly language. So here, EDX register INC means a one value is added to EDX and comparing the value of EDX, 10. So here compares whether the counter has reached the 10 value or not. Okay, if it all 10 value is reached, so JLE, jump less than LP1. If it is less than or equal to 10, then jump to LP1. So here the branching statement has to be executed. It is a conditional branching statement. It can check the counter value whether it is less than or equal to the 10 and it is moving to the specific label in order to alter the control of the program execution. Next, second example, add ax comma 01, increment the one value of the accumulator, add ax bx comma ax bx register values can be added and the result is stored in cx. SHL cx comma 1. SHL means shift left operation. The cx register value has to be 1 bit left shift. Shift left cx, which in turn doubles the cx value. JMP L20. Repeat the statement. So L20 can be the label. So it is a unconditional jumping to the specific label. In this way, the program control statement can be applied in the assembly language. So in this video, we discussed about what is assembly language, what is its features, what are advantages and disadvantages. Next, what is assembler, why it is needed in case of assembly language. Next, what is the instruction format of the assembly language? So, three parts must be specified in the assembly language instruction: the label, instruction and the comment. Here, label, comment are the optional part and the instruction is the compulsory part. These instructions can be, three types of instructions can be specified. One is data movement instructions. Next, data manipulation instructions, program control instructions. Data movement instructions are generally used to shift the content between the registers, between registers to the memory, between registers to the input-output. Next, data manipulation instructions can be used in order to provide the computational and logical power to the assembly language programs. So the arithmetic, logical, shift operations and the mnemonics comes under the category of data manipulation instructions. Next is program control instructions. These instructions can be used to alter the flow of execution of the program either conditionally or unconditionally. And we move to the how to apply them with examples these instructions and how to construct simple assembly language programs with these three types of instructions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.